All right, algebra students, let's look at Unit 4, Lesson 5. And this is about using function notation to describe rules, Part 2. So we're finishing up Part 1 that we learned about earlier. All right, we have 3 goals here. The first couple are kind of long, so you might want to pause to get these down. So the first is, I can use technology to graph a function given in function notation and use the graph to find the values of the function. So we're going to be given equations that are written in function notation, and then we want to use that function notation to make a graph using our technology. And then we'll use the technology to find some solutions. Number 2, I know the different ways to find the value of a function and to solve equations written in function notation. So not only can we use graphing to find values of a function, but we'll also use our algebraic thinking to find missing values of a function. And third, I know what makes a function a linear function. So there are certain things that make linear equations. Those same aspects are also in linear functions. So we'll be looking for those aspects within the function that make it linear. Our vocabulary, we're continuing the same vocabulary for the most part. We have dependent variable, which is our output value from the function. So it's typically our y variable. Function, remember that is just a relationship between two values where we have one input giving exactly and only one output. Function notation is our way of writing a function that should allow us to more efficiently work with the math. Independent variable is our x value. It is also known as our input. It's what we're putting in typically into the function. And then we have our new word, linear function, which the most basic way to define a linear function is a function with a constant rate of change. So we've looked at rate of change in the past. Within a function, if we can look at the math and prove that it has a constant rate of change, it would make a line. We know it's a linear function. All right, so our warm-up is to consider this equation, Q equals 4 plus 0.8 times P. What we want to do is we want to find 4 solutions. What value of Q would make the equation true when P is 7? So if you plug 7 in for P, what Q would you get? For B, P equals 100. Plug 100 in for P, what value of Q would you get? Then the ones that might be a little more tricky, what value of P would make the equation true when? First, we have Q is 12. So if we plug 12 in for Q, we would have to solve this problem to figure out P. In B, Q equals 60. Again, we're going to take 60, put it in for Q, and solve it. Please do the work for that at home, and then bring your explanation or show your mathematical reasoning to class tomorrow, and that will start our discussion. Thanks.